Great to be with all of you this afternoon. A very warm welcome to wherever you might be in Australia or across the world. We are all thrilled to be with you today. We need to understand what really the cold chain supply is. And in essence, it is controlling the temperature range during transit. Now, that may sound easy and simple. The problem is it's not really happening all the time. This can be done by various cooling systems, and most of all, and very important, that you are controlling the manufacturing practices all the way through. Why? To ultimately ensure a good quality of food or an efficacy of a pharmaceutical product. So why is this so important? If one looks at this map of the world, it shows, which I love, it shows vegetables and fruit all over the world. And it's because of us putting pressure on the system, demanding packaging demanding product like fruit anywhere in the world at any time. So if I want bananas in the Northern Hemisphere in winter, I can have it thanks to packaging. But it is putting undue pressure on the system. The system being something like this. If one takes each individual aspect over here, at every point, there's a critical control element that has to be monitored and carefully controlled. Otherwise, what happens is it breaches that temperature range. And this is what is so critical. And this, unfortunately, is what is happening. And we know, especially nowadays, how critical the COVID vaccines are. And some of them, not all of them, require a very specific range of temperature. And we have also read in the press where certain vaccines have been thrown away because they reach that control of temperature, up and down, and not remaining constant. Constant as from the start to the end. And that is critical. I cannot emphasize it enough. I know it sounds easy, but it's not happening. Right from where the product is manufactured on the left-hand image, through packaging into storage, the temperature control element has to be achieved to ensure the shelf life of that product. So if one looks at the logistical aspect like this, there's many folk involved. The responsibility is shifted around. There are different modes of transport, different aspects certainly as we cross countries, makes it even more difficult to control. We've seen these images around our roads and freighting and aeroplanes, etc., etc. And yet the losses continue to happen. And I can give you some latest statistics regarding this. In the pharmaceutical sector alone, because of this lack of control, pharmaceutical, worldwide, global, the losses every year, $14 billion. That's a lot of money. It's a lot of money, no matter how you want to look at it. And this is what we in the packaging industry have to ensure. Now you know why I'm emphasizing this so strongly, because there's a lot of money at stake here. That's only in pharmaceutical. I have not touched yet and given you a statistic on food. So one has to look at every aspect, manufacturing, distribution, and all the way through must be controlled. And we can do that reasonably easy by data loggers. These are little instruments that can measure, document, analyze, and control, and feed that back into a central control, where at any point in the journey of that product, we can see what is happening and whether it's breached. Because you and I, we don't know if the vaccine that was given to us actually breached the temperature controls. And likewise with anything else, not only vaccines. So these data loggers, where they are placed in the container, is critical to get accurate information. Otherwise, the information coming through will not show us exactly what's happening. And you can see here these images of where these data loggers are being placed to give us nice, good, accurate information. In addition to this, there are things called TTIs, time temperature indicators. And there are 5 different ones. And I'll just flow through these reasonably quickly. First one is enzymatic based. So there are enzymes. There's a reaction happening between the enzymes and the substrates, and this causes a change in the pH. And that pH change creates a chemical reaction on the inks and changes that little dot from green to red, which tells us, well, you cannot eat that, or it's not advisable, it's passed into use by date, or there is something the matter with that meat. Or we can use a physical one. This is the theory of permeation, which we call fixed law. And in the theory of permeation, the fatty amino acids, that yellow block, it diffuses through the membrane. And ultimately, you can then see through it. You see the red, and that could be a red dot or whatever the case might be. Likewise, with chemical. For those of you who did some science back in school at university will remember reduction oxidation reactions using photochromic-based type inks, and we can also get a temperature variance or a chemical change that causes the dichromic inks to change color over time. Remember, time, temperature, indicator. We can then also have biological. And these are like microorganisms there. And these enzyme and the spores do the same aspect in terms of biologically there's activity causing a temperature change, and it creates a change in that little dot there of that thermometer where the finger is being pointed. And then, not working. Okay, and then the last one is photochemical TTIs. Now, some of you have seen these. For those of you who drink Coors beer, you would have seen it. Again, they're using thermochromic inks. There's an energy transfer in relation to cold versus ambient temperature. And as that temperature changes, that as an excitement aspect, which creates an energy transfer and changes the color of those thermochromic inks that are being used, that are sensitive to temperature. And there you can see the iceberg of that mountain changing from a normal sort of looking iceberg to an ice cold one, and likewise with the Coca-Cola. Then there are various track and trace systems that we can have in the system by checking on a particular barcode. And I won't, can you move it forward to the next slide, please? Various barcodes can be used, and they are feeding that information to a central database that is tracking that particular consignment of goods. So from a temperature control, it's very critical. Next slide, please. So you can see here all these tracking systems that are happening, and they are vast and extensive, and they will become more and more advanced. Next slide, please. And you can see once we start crossing the world, next slide, we can see a chain reaction happening, because ultimately we have to maintain that temperature. Next slide. And by doing so, we can reduce, through packaging, we can reduce up to about 25% of wasted food. Next slide. So how do we achieve that? We have to make sure we understand the process flow. We have to ensure the critical control points are regulated and we know where they are, understanding where the issues are and the pitfalls, and in that way, we maximize the benefits of the system. So there are different packaging formats that we can use, and here's a snapshot of some of them, the different ones, but we have to ensure that no matter how we pack, that we have structural integrity to that particular problem. This is an issue that we find, and you can see there in the image on the left-hand side, where I'm focusing on that bottom carton, because that's the critical one. In addition, because a lot of these products are moving through a cold supply chain and there's moisture around, we can put a polymer barrier into it. And you can see in the graph how much that then changes the picture of deterioration to the blue line, which keeps a constant. Even though you can see in the bottom, you have condensation happening there. But when we line it with a polymer material, we can then fill the carton up with ice, for example. And this is just, again, some more images showing the different packaging formats in the cold supply chain. So in a pack like this, the positioning of the carton on the pallet is critical in terms of airflow. And that's why I'm showing you different examples here of how the product should be stacked on the pallet to make sure this airflow system happens. Because the days of what we're seeing in front of us here, other than farmers markets, are over. And we're moving into this scenario, which is very familiar to you. And how do we do that? By a suitable cold supply chain. And only in that way will we ensure that we have satisfied customers. Thank you.